vamos começar. Good afternoon, everyone. Today our speaker will give the talk remotely, and it's a great pleasure to welcome you all to today's seminar. And our speaker today is Dr. Evgeny Smirnov. Dr. Evgeny Smirnov works in the field of the dynamics of asteroids. His PhD thesis was related to the identification of two-body and three-body mean motion resonance in the solar system. He introduced a machine learning approach based on the supervised learning to the identification procedure that decreased the computational time from weeks to seconds. And also, he proposed a similar approach for asteroid families instead of the classical HCM method. Thank you, Dr. Evgeny.
Yeah, hello there.
Okay, the time is yours. Okay, thank you.
Okay, so welcome everyone, and thank you for the opportunity to give this talk. Today, I'd like to focus on a more sophisticated topic, the thing I'm working on actively last years. And let me share my presentation. Okay. So today I would like to talk about the usage of commercial and open source large language models in astronomy. I'm pretty sure that many of you have heard or have even tried large language models such as ChatGPT or Claude or Gemini or DeepSeek, and realized their potential in many fields. In astronomy, as well as in science in general, we often start using many tools really late. For example, I remember that the classical machine learning applications in astronomy appeared to be performed in 2014, 2015, whereas in other areas in business, in management, in finance, many companies started using classical machine learning in 2008, 2010. So there was a delay. And even now, when I search, for example, in Google Scholar or in Scopus about the usage of LLMs, there are only a few papers, especially in astronomy, that try to use these tools. And that's sad because many companies realize the potential of this new technology, and it's really different. And today I would like to explain first what to use, second how to use, pros and cons of the usage of different models, and provide some examples. There are not too many examples in the field of astronomy, but I will try to do my best in terms of outlining them, as well as providing some other ideas of what could be done so far. Before going to LLMs, let me briefly outline that when we say artificial intelligence, sometimes we might mean different things. And I differentiate artificial intelligence and machine learning into two areas, like classical machine learning, which is essentially statistics. It's not something really intelligent. Of course, it depends on the definition of the word intelligent, but it's just statistics when we have some data and we would like to do some data mining against this data. If we remember the first well-known case of the usage of classical machine learning, it was provided by Google when Google realized that they have a lot of data. They have big data on some stuff. That example was related, I think, to the pandemic of flu in 2008 or 2006, something like that. And based on the location of the people who were searching in Google some symptoms about flu, Google was able to predict how the pandemic will spread across the United States. They didn't do any intelligence. They were just using statistics and classical machine learning algorithms such as nearest neighbors or decision trees or gradient boosting in order to perform such a prediction. Later on, it was spread across multiple industries, including, for example, Facebook or Amazon. So, for example, if you ever used any of these tools, when you open Instagram, Facebook, or when you try to buy anything on Amazon, the recommendation system is based on the classical machine learning, and it proved their efficiency. But at the end, that's just statistics. And it works really well when there is a lot of data and we could find some temporary or contingent regularities within these data. The next level is related to neural networks, where we can train several layers, especially hidden layers, in terms of how to deal with the concrete set of data. So, for example, if you have a task where you need to perform something like categorization of texts, images, videos, whatever you have, and you have enough examples, you can train a neural network based on your task and different architectures of neural network. And then when your neural network is trained, you can use it to make a prediction based on the new data for any new piece of data. It worked really well, and I'm pretty sure that you might be familiar with multiple applications of neural network in astronomy, starting from celestial mechanics and dynamical astronomy, and I'm working in this field, so therefore I know more examples from this field, but there are some other applications in other fields as well. Whenever we need to perform anything on big data, such as I don't know, curves, light curves, images, videos, neural network can do a good job there. However, the main disadvantage of the usage of neural network is that first, you have to train it. And this is a pretty complex procedure. Even if you know what you do or what you have to do, you have to prepare the initial data, the training data. You have to find the right architecture. You have to have enough data. You have to spend some time on data preparation. And what's more important, if let's say your neural network works well on some piece of data, it doesn't necessarily imply that it will work on other piece of data. So neural networks can be used in some examples, and we know a number of good applications, but the technology goes forward, and nowadays we have large language models. And I would demonstrate today how they can supersede, how large language models can deal with some of these disadvantages, and why they could be a better option, a better choice, rather than neural network. So, as I mentioned earlier, AI has been artificial intelligence, or what do we call artificial intelligence, has been involved from classical machine learning and some data prediction, such as recommendation system or categorization system, to something which is called conversational AI. And that's also the difference, because when, for example, we are dealing, let's say, with postgraduate students or with graduate students or with other researchers, we do not use training data sets to explain the task. No, we explain it in natural language. Like, for example, hey, I'm sending you 20 images of this stuff. I have categorized it. Could you please verify whether everything looks good, or whether I'm wrong somewhere, and if I'm wrong, please specify why it is and how it should be categorized. So that's how we formulate such a thing. And we cannot interact with classical neural networks or classical machine learning in such a way, but we could do that with large language models. And that's a benefit because we don't need to transform our language. We don't need to transform our data into something which is unnatural to us. Another important feature of large language models is that they are multimodal. In other words, as inputs, they could accept almost anything. In general, they accept text, but text in a broader sense. By text, we could text is everything. Text is real text, like a book, an article, a conversation, an email, etc. But also an image. An image is also text, as well as a video is text. So everything seems to be text, and for large language model, it doesn't really matter which format is used. And that's great. A lot of that's really helpful because, for example, as you might know, in astronomy we use different types of software, and some pieces of the software have been developed a long time ago. And for example, today we use some standards such as JSON, CSV, XML, and others. But these formats were introduced and were popularized not long time ago. And there are some pieces of the software that have been developed before that. Conversion from one format to another might be painful. In terms of LLM, it doesn't really matter. You just upload whatever you have and you get the result. However, when we are talking about large language model, we talk with a model through the natural language. Like if, for example, we had a student and we would like to assign a task to the student, and the interaction with an LLM is like interaction with such a student. So, for example, if you want to classify some images and label them in some way, you can just say like, I have these images. On these images, you can see this, and this. You have to classify it by the following rule or by the following algorithm: first, second, third, etc. So, however, as you might realize, if, let's say, you have a student that knows something in astronomy, but isn't expert, isn't professional in the relevant field, if you specify the assignment, the task, if you do not specify it properly, if you do not specify it clearly, fully, etc., it would be the case that this student wouldn't do it in the best possible way. Because, of course, in order to do some scientific task, the student has to have some scientific background. And when we are dealing with LLMs, the same approach works. So yes, it is some sort of black box, but many people interact with an LLM like it is placed situated in their brains. Of course, at least at this stage of technology, large language models cannot read our minds. And if something is clear for us, it doesn't mean that it will be clear for an LLM. So whenever we interact with ChatGPT, with Claude, and it doesn't really matter how do we interact in terms of in code, in application, or through the API, if we provide bad instructions, unclear, not full, etc., we usually get unacceptable result, unacceptable response. And I just want to emphasize that the quality of the usage of large language models highly depends on how do you provide instructions, what kind of instructions you provide. That's why, for example, it's a good idea if you are if you are not familiar with how to prompt, how to send instructions to an LLM, it's a good idea to Google it. There are several online courses which are available for free that can help you to master this skill. In artificial intelligence, it is called prompt engineering, and it's really it's worth investing time into this skill, because the result could be dramatically different. Let's say 50% of accuracy versus 100% of accuracy. So when we are talking about the instruction, previously we had to pay a lot of attention to different aspects of instructions which we send to an LLM. These days, LLMs become smarter. So therefore, for example, if you interact with GPT-5 or Claude 4.1 Opus or Claude 4.5 Sonnet or Gemini 2.5. These are the latest versions of the most well-known commercial LLMs. So if you interact with them, you can actually structure your prompt in multiple ways, and they could handle that. However, when we interact with smaller LLMs, which could be the case in astronomy, because sometimes it might be a better idea to use smaller LLMs, and I will explain later on why. It could be a good idea to structure and specify some sections of the instructions of the prompts you send to an LLM. And usually they have several sections. For example, a system section which explains the context, the background. So, for example, you might want an LLM to act as an astronomer, or if, for example, you have created a draft of the manuscript and you would like to get a second opinion, you can say something like, "I want you to act as a potential reviewer in, I don't know, in Icarus or in astronomy and astrophysics." So then the core, the essence of your instruction, what you would like to do, it's like a simple instruction, simple, clear, straightforward, written in a sequence or in some other logical way. And of course, the output. When you interact with an LLM in the application, like, for example, you can go to the website chatgpt.com or claude.ai and ask a question, you don't really care what output you will get. You will anyway read it and then use pieces of this output for your needs. However, when we are talking about the usage of large language models on scale, like, for example, imagine that you have a telescope, or if you have a software that produces hundreds or thousands or hundreds of thousands of images, you don't want to review the results, the responses of large language models manually. You would like to automate. And large language models are really good in transforming data. So you can ask it to output the data in the format you want. The easiest way, of course, could be something like 1 for this, 0 for this, -1 for that. But if you are using some modern software, you might want to ask it to transform the results in JSON format, in XML format, whatever format you may use. That's really helpful because you don't need, as a researcher, you don't need to spend extra time on this technical task. And that's actually also an important advantage of large language models, because they help to cut some corners. As astronomers, as an astronomer, I always believed that my primary occupation, my primary task is to perform research, to think, to analyze the results, etc. But in reality, especially when I was doing my PhD 10 years ago, 80% of time I spent on coding. I had to code this piece, that piece, then analyze, then fix some bugs, then run some tests, etc. 80% of my time was spent on coding, and 20% was spent on science, on actual science. And when we code anything, we spend tremendous amount of time on transformation from one format from one interface to another. With LLMs, we don't need to care about that because we could simply say that, please, here is the format I'm using in my software. Please format the output in this format, use this format. And that's it. That's all what we need to say. There could be some other stuff as well, some ad hoc stuff. For example, if you know that there could be some edge cases or extra instructions that could be helpful, you may want to add it to the prompt. And in this case, they will increase accuracy. So, for example, when I was doing my first research on this on LLMs, on the usage of LLMs in astronomy, the default prompt I created and tuned achieved about 85% of accuracy. However, when I spent some time on modifying this prompt and adding some edge cases and explaining how to classify them, I was able to achieve accuracy up to 100%. That's the difference, and that's what we could do with the prompts. In any event, to sum up, prompts are essential, at least at this stage of the development of LLMs. I believe in 1 or 2 years, it will not be so important because LLMs could do this on our behalf. But for now, they are essential if you would like to achieve expectable and reasonable results with LLMs. So again, it's worth investing some time into that. Of course, when we are dealing with LLMs, we have to familiarize ourselves with the tools used. Although LLMs are really good, and for example, I'm pretty sure that you've at least heard about 3 major players on this market, such as ChatGPT by OpenAI, Claude by Anthropic, which was recently renamed to Claude. The company was renamed to Claude, and Gemini by Google. So these are the most well-known commercial LLMs, but behind the scenes, there are some other packages, some other projects that might be helpful to familiarize with. It's a little bit tricky because this market and this area is evolving really rapidly. So, for example, something which is, I don't know, trending and helpful today might be outdated in a month or two. Something that was, let's say, important a couple of years ago doesn't work anymore. For example, the first LLMs such as GPT-3, GPT 3.5, or Claude Opus and Haiku and Sonnet version 3, they were unable to work with images. So you were able to send only text requests and get text responses. So some people created special software packages to handle images. However, OpenAI introduced a year and a half ago a special model which was called GPT-4 Vision Preview, which was truly multimodal, and it was able to accept images as inputs. So therefore, these projects were outdated, who were dealing with images while the LLMs were unable to parse them properly. That's why I'm pretty sure that some of these projects, which are outlined on this slide, they might be soon outdated. For example, there is a project, 2 projects which are called FlowWise AI and NA10. These are no-code tools. No-code tools, these are the tools that can be used by anybody, not only by programmers. So, for example, if you are not a programmer, or if you don't like to code, you can use any of these tools in order to create some workflows, some sequence of action without coding anything. So, for example, you can simply download NA10. It's an open source. By the way, all these tools are open source, so you can download and use them for free. They have also cloud versions, but and you can use them as well. But all of them are open source, so therefore it's free to use them. So, for example, you can go to NA10 and create a simple workflow within a minute or two, which, for example, can take an image of telescope as input, perform some actions, and then provide some outputs. You don't need to code anything. The only thing you need is two things you need. The first one, you have to familiarize yourself a little bit with this tool, but it's not so difficult. Plus, there are many guides on YouTube as well as in ChatGPT itself. And second, you need to specify the prompt. In other words, you need to write in natural language what to do. And that's all what you need. So these tools are really essential these days if you would like to automate some stuff without coding. However, I'm pretty sure that in a year, the large companies from these list, they will create something similar on their own platforms, and therefore that tools wouldn't be necessary anymore. So, long story short, the industry is evolving really rapidly. So therefore, it is hard to say what are the essential tools and what tools could be essential in, let's say, 1 or 2 or 3 years. But these are something these are the tools with which you can start. For example, I mentioned already Flowwise AI and NHN. These are no-code automation tools that helps you to build some AI workflows with using LLMs, with the usage of LLMs without coding. You can also use Hugging Face, which hosts a lot of open source large language models, smaller large language models, not commercial, usually open sourced. And they have some special models. For example, there are some astronomical models as well. LangChain is a framework that is often used when you code. So, for example, if you prefer coding instead of creating visual blocks, visual schemes, you can use LangChain or any other library. With LangChain, you can utilize LLMs within a few lines of code. So, for example, I was doing some research, and as a part of this research, I was producing images. I was producing time series, but then I had to analyze this time series. And in order to do that, I used multiple algorithms such as LLaMA periodograms. That's some sort of time series analysis which extracts frequencies, especially when you have really noisy data. And then I had to compare different frequencies, find some overlapping, etc., etc. So it's not a big deal if you know what to do. But when I was doing that for the first time, I didn't know a lot about that. I had to familiarize myself with all the background. So it took some time. Instead of doing that, what I could do these days, I could use LangChain, write about 3 or 4 lines of code. It would be something, take GPT-5 or GPT-5 mini as the model, then here is what you have to do, and then specify the prompt, and then assign the result to the variable. That's all what I need to do. I don't need to know about LLaMA periodograms or about frequencies or about anything like that. So LangChain is some sort of a library that helps you to deal with AI requests really easily. But in any event, many of these tools will be replaced by large players at some day. Therefore, it is also a good idea to familiarize oneself with the functionality which is already available in these platforms. So many people consider ChatGPT or Claude as just magic box where you can ask a question and get a response. Yes, you can do that, but you can do much more there. So, for example, both ChatGPT and Claude have projects. So what is project all about? Let me show you in reality how does it work. Let me share another screen. Okay. So this is my personal account in Claude. And for example, I have projects. What is project? Let's just create a new project. Project is functionality that helps you to configure a little bit an LLM. So for example, I could call it, I don't know, what is the area I'm unfamiliar with? For example, okay, binary asteroids. Now, what I could do, I mean, that's the same chat as you might see in other applications, but what I can do here, I can add some files. So let me add a few files here. I will just open some random papers in binary asteroids. Let me just find 2 of them. Okay, for example, this one. Okay, that's the first file and the second file. You can upload multiple files. As you see, I'm just drag and drop, perform drag and drop here. And now I can ask any question about these files, as well as I can ask AI to ground all reasoning on these files only. For example, there is here a section called instruction, and here I can say something like, I want you to act as an astronomer specializing in binary asteroids. I uploaded some papers. Provide your answers based solely on the papers uploaded. Of course, you can write something more complex, but that's just an example. And now, when I ask anything in this chat, in this project, I would get responses based on these sources, as well as I would have some references to these sources, which is essential when we do any scientific research. So, for example, one of the article was about binary asteroid, to a pair of binary asteroids, 7343 and another large number. So I can ask, what do you know about? Okay, it will think a little. It will think a little bit. While it's thinking, I would just specify again. So this functionality is already presented in both Claude, ChatGPT, and even in Google Gemini. So that's just one piece of the functionality. There are other stuff as well. So for example, in Claude, there are artifacts, there are data sets, there is an ability to write code. That's something that does not require any training. You can just go there, click, and see what could it do. Furthermore, almost every week, something new appeared. So for example, today, I didn't plan to do that, but today when I opened this website, Claude.ai, because I wanted to prepare a little bit for the talk, I just realized that Claude has released a new feature. And let me just show you these results. While we were talking, I was testing this feature. Here is it. They created functionality which allows to use external applications on the desktop. And as an example, I asked, please make me a 4-page PowerPoint presentation about mean-motion resonances. And here is it. So it created, and I can now download it or put it in Google Drive. They just created that, and I didn't read it yet. But okay, Galilean moons seems to be Pluto and Neptune. It seems to be valid. I didn't provide a reasonable prompt. You see, it's very short. And of course, if I would like to create a good presentation, like for example, the presentation for today, unfortunately, I found this functionality really late. If it was released yesterday, then I would be able to create my today's presentation with with Claude. But if I write a better prompt, that could save really a lot of time. So to sum up, even standard applications such as Claude or ChatGPT, they have a lot of functionality which you can use, and this functionality evolves almost every day. So it's worth familiarizing oneself with this functionality. Okay, let's go back. What else is already available? The last line, MCP and tools. It looks complex. It sounds complex, but what are these things? MCP is a special protocol that allows different AI applications interact to each other. It's like a language to AI products, AI applications, AI software. Why it is essential? Because it is standard. So if a service supports this protocol, you can use it, and you can use it from your code or from your ChatGPT application or from your Claude application, from any another application that supports MCP. Why it could be helpful? For example, a famous website archive where many astronomers publish their preprints. It has MCP server as well. So in a few clicks, you can add this MCP server to your ChatGPT instance. Then you can specify on every request whether it should use this MCP server. And if you allow to use it, every scientific astronomical request you will send to ChatGPT, it will search on archive, find relevant papers, and use them as a source of knowledge to respond to you. And that's just one example. In business, there are many more examples. Like, for example, you can connect your email account to ChatGPT or Claude. And if, let's say, you need to find some emails where you were talking with your colleagues, I don't know, about publishing a paper in astronomy and astrophysics, instead of searching or Googling, you can simply ask ChatGPT, please find me an email where I was talking with John Doe about publishing a paper, and it will find. It is possible because of these three magic letters, MCP. MCP and tools allowed you to extend the standard functionality. And these are programming protocols, which implies that if you create a software or if you create some automation, which is the case often these days, you can also use the same MCP tools in automatic mode. So, for example, if you need to perform some automatic recognition and there is some service that can do that, you can simply connect it. That's the state of art which we have today. It's already complicated because, yes, artifacts and MCPs, they were unknown to the major population like a year ago. Furthermore, even today, everyone is talking about ChatGPT, but less than 20% of population has heard anything concrete about ChatGPT, and less than a few percent of the population are using ChatGPT on the regular basis or any other AI tool. So we are talking about a narrow niche at the moment, but it is growing really rapidly and it's evolving so fast. So new terms and new technologies appears almost every day or every week. So let's talk a little bit about the current applications. As I mentioned earlier, there are only few papers that have been published and that have been utilizing large language models in some real context. So the first paper, I've mentioned it implicitly earlier on. It was written by me a year ago. And that was the first attempt of visual recognition and visual categorization of astronomical images using LLMs. So the idea was very simple. I wanted to check whether it is possible to classify astronomical image without specifying any algorithm, any astronomical data. Just say, here is an image. That's how you can classify that. Explain this in natural language in a short prompt, and that's it. So the coding of this functionality, it took about 15, 30 minutes. So it was really hard. It was really fast. And what I wanted to check whether it could provide reasonable results. The results were really good. I was even surprised because GPT-4 Vision Preview, the previous generation of GPT model, it was able to achieve 100% accuracy. It was much better than even human visual inspection because humans tend to make mistakes as well. In terms of LLM, it worked really perfectly. And for me, it was a good example of how to do something really quickly. And when I was doing PhD, I had to do the same image classification. And I remember that I spent almost a half of a year to make it in such a way that the results were good enough. They had good accuracy, precision, recall. They were robust and stable, and they could deal with almost any type of images. I spent a lot of time on doing that. I was able to repeat the same stuff within 30 minutes with an LLM. That's the benefit. Instead of focusing on software development, it is possible to focus on a real scientific task. 30 minutes within 30 minutes versus half of a year. Another interesting research in the field of large language models is about creating benchmarks. What's also important, I didn't mention this previously, but there are many different LLMs. There are many large language models, and they differ. For some, when you just try to do something, it doesn't really matter with which LLM you start. However, if you deal with LLMs on the daily basis, regularly, soon you will find out that for some tasks, one LLM is better than another. For example, my personal subjective experience is that if you need to do some math, astronomy, coding, it's better to use GPT-5 Pro or GPT-5 Code. However, if you need to perform some social research, some, I don't know, philosophy, psychology, literature, etc., it is better to use Claude 4.1 Opus. But that's my personal suggestion. But in reality, of course, they differ. And there are so-called benchmarks that help to compare different LLMs. We are not so interested, I think, in comparing in regular domains. So, for example, there is a legal benchmark which compares different LLMs based on the bar exam. That's the exam that every lawyer has to pass in order to obtain license in the United States. And that's some sort of a standard exam which is used as a benchmark for commercial LLMs. It's not so important in terms of astronomy. And that's the paper where a few astronomers from MIT created a benchmark in space science and compared different commercial and open source LLMs in terms of whether or not they could resolve some astronomical tasks of level, some sort of, let's say, graduate, postgraduate students, something like postgraduate student. And they compared different LLMs. They found that, of course, commercial LLMs outperformed others. But why this research is helpful? It is helpful because when we go further and when we start using LLMs actively in astronomy, we would have to run some benchmarks in order to find out which LLM should be used for this task, which LLM should be used for that task, etc. I'm not talking about pilot studies. For pilot studies, we could use whatever we want. It doesn't really matter. But if we plan to use seriously LLMs in astronomy, for example, perform automatic sky surveys using LLMs without human interactions with acceptable accuracy, we have to find out which LLM to use. And a standard for benchmark is really appreciated. And these authors tried to create such a standard in astronomy, and I think they did a good job in doing that. Another interesting, but still not very useful, let's say, research was several astronomers tried to fine-tune an LLM, an open source LLM, on a data set of astronomical papers from arXiv. So fine-tuning is something like adjusting an LLM to a particular data set. So you can imagine it as, let's say you have a student, a general student after the high school, and you can either put him or her in mathematical department, philosophy department, psychology department, or sport department. Of course, you will in 4 or 6 years, you will get different people with different skills and different knowledge. Fine-tuning is choosing the right direction of adjusting the relevant skills or mathematically relevant weights of a large language model. So these authors tried to fine-tune as an open source model. They took a number of articles from arXiv, converted them to a special dataset, then used this dataset to improve the original model, and then compared the results. What's really interesting, they report that they got really good results and they outperformed the original open source model, whereas these guys said the opposite. So it's really interesting whether or not fine-tuning on astronomical data could make a difference. In any event, that's something what we already have in the field of large language models. What's the current stage? What's the current stage, and what's the nearest future? I believe that the nearest future is in agents. What is the main disadvantage of the current software, the current, let's say, popular software, such as ChatGPT or Claude? The disadvantage is that if I need to do something, I have to ask ChatGPT, then read the response, and then process it in some way. So in other words, it's like interaction, input, output, input, output. It's not fully automatic. I still have to read something and sometimes adjust. For example, I could say, please find me 10 asteroids trapped in secular resonances. It could find 8. And I would say, no, I asked 10, please add 2 more. It will add 1. I would continue 10, not 9. And at the end, it will make 10. It occurs because of multiple reasons, because first of all, these LLMs are not real artificial intelligence yet, as well as there are some other technical problems. So for example, if many people ask ChatGPT at the same time, simultaneously, their service might be too loaded, and therefore the quality of the answers, the quality of the responses starts degrading. So for example, if let's say you try to ask ChatGPT in the night, in the American night, like when you're in the United States, when people from the United States are sleeping, if you ask at this time, and then let's say you ask the same question when they go to their work, like 8 a.m., 9 a.m., you will realize almost every working day that there would be a difference, because when Americans are sleeping, there are not too many requests to ChatGPT and other LLMs, whereas when they are working, they ask a lot of questions. Or when they are studying, because all students are also essential audience of LLMs. But in any event, LLMs can do a good job, but sometimes they require extra inputs from human beings. And that's the thing that could be resolved with agents, because you don't need you don't need a special intelligence to say that 8 isn't equal to 10. So you can imagine it as not just one LLM, not just one intelligence, but a group of intelligence. And there is a supervisor, and this supervisor has just one task, one duty, to check whether the output of the executor meets the criteria set by the user. So, for example, I ask an agent, please find me 10 asteroids in secular resonances. So, supervisor extracts the relevant information. I should get exactly 10 asteroids, and these should be the asteroids trapped in secular resonances. So executor starts executing the task and returns to supervisor 8 asteroids. Supervisor would not respond to me with these 8 asteroids. Instead, it will loop executor again and ask to find extra 2 asteroids, etc. So it just saves time. And this example is really simple with 10 secular asteroids, but imagine a little bit more complicated task. So, for example, create a software that can find out whether an asteroid is trapped in a secular resonance and test this software against well-known examples. Find these examples on arXiv. I'm more or less confident, with let's say 80% of confidence, that if you run such a task in agent, it will be done, even with the current level of technologies. And there are 2 tools that could be helpful for such a task. Many people consider these tools as tools for programmers. They even called, like, the first one is OpenAI Codex, and the second one is Claude Code. So even their names suggest us that these are the tools for the developers. This is true. These are the tools for the developers, and the developers are using these tools a lot. However, it doesn't mean that they could be used only by the developers. So, for example, if you need to run, if you have some, I don't know, statistical data, and you need to perform a statistical analysis, create a script in Python or R, run some tests, I don't know, t-test or whatever you are using, then analyze the results and then prepare a draft of the manuscript or a draft of the results section of the manuscript, you can use these tools as well, because you need to run some simulations. It could be done in Python, which is programming language, so therefore both tools are good for that. You need to deal with the data. The data could be stored in Excel or in CSV format, which is good for both tools as well. Then you need to write LaTeX. LaTeX is also text, so therefore it is also good for both tools. So such a task could be easily done in both tools. So yes, they require some knowledge of the command line, because you can invoke them from command line. These days, I believe you can also use them, you can invoke them from the website, because I have heard that they introduced visual user interface for these tools as well. But frankly speaking, I didn't try that because I'm using it in command line. But in any event, both tools could be used for such tasks as well. As well as if, let's say, for example, you have a library of 500 PDFs and you would like to know which PDFs have something like, for example, we've mentioned secular resonance. Okay, which PDFs are talking about I don't know, Z1 secular resonance and providing some examples of asteroids trapped in this resonance. You can do this with these 2 tools. You just put your PDFs into a folder, run Codex or Claude within this folder, and just say this instruction. In this folder, I have PDFs, read them carefully. If these PDFs are about Z1 resonances, please put them into Word document or any other document. That's it. So this is something that is already available. And again, let me just provide you a real example. Okay, here is it. So when I was talking about circular resonance, actually I was providing some real life examples. So for example, I needed to run some benchmarks, and here in the left you see my interaction with it's not my interaction actually with Claude Code. I just somewhere in the top, I added a prompt, please do something. And here, as you can see, it creates, it runs, it updates plan what to do. So when I asked to do something, it created a plan, what to execute. And then a few times it updated the plan in order to reflect new findings. It runs some checks, it checks the difference, it explores. So it could work for a couple of hours in order to achieve the results. And in order to be able to do that, I don't need to be a coder. I just need to write code. And then, for example, sorry, that's wrong. I need to run Claude. And here I could say whatever, like make a documentation of the whole project in Brazilian language. Make sure that it is up to date. That's all what I need to do, and it will realize that I would that this is a code, this is a project. It already uses Markdown format, so therefore it will create Markdown file, and yeah, it's already doing that, as you see. And that's just a simple example. So sometimes it requires some permissions because I didn't have this permission, but in any event. Okay, let's go back to our presentation. In any event, I believe that the nearest future is in these agents who will be able to perform more complicated tasks and resolve more complicated problems rather than regular response to user's question. Okay. Okay. What's the main disadvantage of LLM? The main disadvantage for an LLM is money. I'm not talking about a subscription. I'm pretty sure that it is possible to find out a few dollars to buy a subscription, plus there are free accounts, plus there are some free LLMs, etc. So it is possible to use LLMs for free or for a limited budget. However, when we are talking about real astronomical problems, it wouldn't work because, for example, if we would like to analyze some telescope data, we are talking about terabytes of data, and it will cost millions of dollars. So the use of ChatGPT or Claude, even if there is some agreement with these companies, it will be too expensive. Therefore, it is worth exploring some alternatives. And that's what I'm working right now, and I can share some preliminary results on that. So there is a website which is called, there is a tool and the website which is called LLaMA. This is a catalog of open source large language models. There are two important things. The first one, they are open source, which means that you can use them for free without necessity to pay for any type of usage. And second, some of these models are small. Why does it matter? Because I'm pretty sure that some of you might heard about LLaMA 4. That's a model, an open source large language model built by Facebook, or DeepSeek, or GPT-OS. These models are really good and they could provide pretty good results. However, they are large. So for example, you cannot run them on your laptop, even if you have a good laptop, almost, I'm sorry. Even if you have a really good laptop, you cannot run them because they are too large. You need to buy special software, special GPU units, which are really expensive. Some labs can afford that, but definitely not a regular astronomer, especially with our salaries. But in any event, there are some models that are small, and these models, you could run them on a reasonable laptop or reasonable computer. Yes, it should have acceptable performance. So you will need something like 16 gigabytes of memory, but this investment is not so huge, isn't so huge. 16 gigabytes of memory will cost, I don't know, $200 or about so. And on this LLaMA service on the LLaMA website, you can install for free these small models, and you can use them as if you were using large models. They work and operate in the same manner. You send a request and you get a response. Furthermore, some of these small models are that's how this website looks like. And here, if you click models, you will get a list of models. And here you can filter, for example, by the tag, which is called vision. Vision means that you can use these models, and these models accept images as inputs. So if you need to categorize images, you can use any of them. And for example, here, Gemma, that's the open source model created by Google, 1 billion parameters that could be easily run on a regular laptop. You don't need something extremely powerful in order to be able to run it, as well as okay, LLaMA 11B is a little bit more complex. I'm unsure that it could be run on any, but Gemma for sure. So with these models, you can do pretty much the same, but of course, the quality is lower. At this stage, I've been doing together with Valerio Karuba some benchmark that compares the results of commercial and open source LLMs, and what's more important, small open source LLMs, because these are the LLMs that anybody can really use in astronomy without paying to somebody or without buying some expensive GPU unit. So far, the results are the following. Of course, commercial LLMs are much better. So for example, GPT-5 and Claude 4.5 and even 4.1 and even 4.0 outperform all these models. Large commercial LLM, large open source LLMs such as GPT-OS, DeepSeek, and LLaMA 4, they provide pretty acceptable results, even good results comparable with the previous generation of commercial LLMs, such as, for example, GPT-4o or Claude 4.0 Sonnet or even 3.5. Small LLMs underperforms. Furthermore, their accuracy goes down dramatically. And for example, if I can achieve about 99, 100% accuracy on commercial LLMs, I could achieve 95% accuracy on open source, but large LLMs. On small LLMs, without significant work, I could achieve something like 65, 70% of accuracy. However, it is possible to fine-tune these models on a particular task. Yes, it introduces the same problem as for neural networks, that you would have to tune a concrete large language model to a particular task, which requires some time and efforts. But at least the interface is the same. This research is still in progress, but preliminary result and pilot study suggest that small models, such as exactly Gemma 1B, they could achieve 95% performance accuracy and 95% accuracy on the same task. So in reality, what does it mean? In reality, it means that, okay, there is a good use of commercial LLMs if, let's say, you have a few images or 100 of images, or if you need to code something, or if you need to write a manuscript. In other words, you need to perform one-time action, which does not require a lot of data, the transfer of a huge volume of data. However, when we start talking about the real astronomical volumes, when we start talking about real applications of large language models to astronomical problems and analyzing, for example, gigabytes or even terabytes of data, the use of commercial LLMs is almost impossible because it's too expensive. If it is possible, of course, GPU units can handle large open source models. But even with small models, it is still possible to achieve reasonable results without coding or doing something complex. So fine-tuning of small models, it seems to be working, but for now, that's just the results of the preliminary study. I believe within a month or two, these results will be finalized, and I will be more confident in terms of saying whether or not this is the case, at least on some tasks. Okay, I think I stop here. Thank you very much.
Thank you. Very nice talk. We have time for questions. No questions from Google Meet? From YouTube? No? Okay, then thank you again.
Thank you.
We finish.